made a run for governor or something of this. I mean, it was a pretty big run, and he was had known Klan ties. But other than that, years. Okay, questions on number 10.
A through E sound good.
Let's see here. Oh, I'm in my appendix. That's why I'm having problems here. Oh, I know why I'm having problems. I'm in chapter 3, or chapter 4. Now we got it. Okay. So, diagram below illustrates market for beef. Suppose that the government has instituted a price support program for beef by placing a price floor at $4 a pound. Under the program, any unsold beef will be purchased by the government and placed in long-term storage. Okay. So what's your question first, Taylor, since you brought it up?
Well, I guess I was just really confused on the change in rates to surplus. Because I kept getting the wrong answer and I wasn't following how they worked it out.
Okay. Do you think the solution was wrong?
Probably not.
Okay.
Not understanding.
Okay. All right. Which part was the change in consumer surplus? C. All right. Well, let's walk through the details. I want to see if their graph looked all right. Yeah. We did a similar problem to this in principles with the buying the grain back. The government buys the surplus corn. I don't know if you remember that one, but it was kind of the same idea because this was based on reality. The government, in an effort to help farmers, set a price floor that caused a surplus. And they're like, whoops, we didn't mean for farmers to have unsold corn. I got an idea. Let's buy the corn back from them. And then they put the corn into bins because they couldn't get rid of it because nobody would buy it at their legal price, and so it rotted away and got wasted. So with this problem, price floor causes what? Surplus or shortage? Surplus, because the quantity supplied is here and the quantity demanded is here. However, the government's going to buy back the surplus. Which triangle? Did you say triangle?
Yeah.
Okay, let's think about that for a moment. What was the floor price in this problem? $4. Okay, and did you guys solve QS and QD all right? Oh, that was given. Okay, what's the quantity supplied? How much? 1.5. And how much is this? 0.5. Okay. $3. And what was the
Quantity is 1.
Oh, at 1 in here. Yeah. Okay, so how much is the government spending on the program? I assume this is measured in millions or something, or thousands, or? So there's 1 million units of beef. How much are they spending? What's total government spending? $1 million? How much are they paying for it? What are the farmers expecting? What are the cattle ranchers expecting? 4. So how much is the government spending? 4 million. So government spending on this program is they have to buy all of the surplus, all 1 million units of beef, 1 million pounds, is it pounds or? Okay, so 1 million pounds of beef have to be purchased at $4. So this area here, this rectangle ends up being the amount of government spending on the program. So, part C asks for what? The change in producer surplus? Okay, so what did the producers have? What was choke price here? Okay, did you solve it? Oh, no equations. Okay. So, because they're just asking for the changes? Okay. So that way we can actually do it without that. So producer surplus, free market is here, right? And what's the producer surplus after? Trapezoid? Does the beef farmer, cattle rancher care whether the government buys it or whether people buy it? Do they give a rip? No, because they still get $4. So producer surplus is the difference between the amount that the producer actually gets and the minimum amount they must get for each unit sold. How many units are being sold? 1.5 million. Consumers are buying 500,000. Government's buying 1 million. Farmers selling it to, doesn't matter if it's the government or the consumer. So the new producer surplus is the difference between what I actually get, minimum, actual minimum, actual minimum, actual minimum, actual minimum, actual minimum, to each unit I sell. It's this big triangle. And so the difference, we started here, we ended here, and so the change in producer surplus is this area. Right?
Where's consumer surplus? Is it above the price floor?
Mm-hmm. Because the consumer surplus is the difference between what a consumer is willing to pay and what they actually pay for each unit that they consume. So what the producers are producing is not what the consumers are consuming, because the government's buying it. So their quantities here, which is willing to pay, actual, willing, actual, willing, actual, willing, actual. So the consumer surplus is right there for that's the new consumer surplus. Now this problem said what's the change again, right? Or did it not even ask for that part?
Well, in part A, I think it asked for the loss of consumer surplus.
The loss of consumer surplus. So then they're losing, they used to have free market, they used to be buying 1 million, right? So their consumer surplus before was this amount, now it's shrunk to this amount, which means they lost this little trapezoid. If I, let me grab one more color here. The green and red area, which I think is what your book highlights, right?
What was part B? There was a question. I didn't do it, so.
Oh, what was part B?
The cost to the taxpayers.
Yeah, I think I just saved
You want me to go over it, or are you just wondering what it was?
I know it.
What is the cost to taxpayers to purchase the unsold beef? So that was this, 4 million. What is the cost to taxpayers? Yep.
Okay. So the producer surplus was, what was the formula again?
The producer surplus, they gained this area. you're going to have to do some math to get the that area. So you've got a rectangle plus this little triangle, or you can break it up probably maybe a couple different ways, but you've got a rectangle, base times height, and then you could calculate this triangle 1/2 of base times height, add those two together, and that would give you the area. Okay. Does that knock all the questions out for this problem?
I also have D.
D. What do we got? Society loss. Oh yeah, this is a good one. So for society's loss, we want to look at in general, the change to consumers, the change to producers, and the change to government revenue. So back to our shoot, I don't have it again, and I like to use that when I can. Our circular flow diagram, this captures all the agents in the economy, right? So what's happening to consumers, what's happening to producers, what's happening to government, and then we add them up. And in this case, the change in consumer surplus is something negative. Negative 0.75. Okay, right. And producers gained how much? 1.25. And then government, yeah. Did they gain that? Positive sign or negative sign? It's revenue. Is it revenue that they collected, like a tax? The government spent it. So it's expenditure. So it's negative revenue minus 4.
That's not what they have.
Oh, that's because they characterized it as the loss to society. So my number is going to come up to be a negative, which is the total loss, but it's a negative number. So that would be the deadweight loss. Although, so the way we drew it up here, there's potentially a gain. If it's a negative number, it's a loss. Which was negative 3.5. Okay, anything else on that one? This one's loaded with fun stuff. We've come this far with it. Since I'll refresh you, and Colby, you probably likely didn't see this because I don't think it's standard in most applications. But the other government program we looked at was the deficiency payment program. And I guess you didn't have me, Max. You didn't have me for principals class either, right? Adam, you did. So the deficiency payment program, which is a current program that the United States government uses, was somewhat in response to this going on, that we have this big waste. The deadweight loss to society is pretty huge for this being not a very good answer, especially with the corn going to waste. And so what an economist, I'm not sure who to give credit to, designed was the target price program. And so instead of setting a price floor, we say, farmers, we're going to guarantee you a $4 price. You go sell it to the market, and we'll make up the difference with the deficiency payment. So how that looks is fundamentally different. The producer still produces 1.5 million, but now we're going to let the consumer buy all 1.5 million of it. Government doesn't buy and hold any of it. So they go up to the demand curve. Consumers are only willing to pay the market price we call PM. You know, who knows what, we don't have functional forms here to calculate that. And then the government's going to make up the difference with a deficiency payment. So if this, again, just making up numbers, turned out to be $1.50, then the government's going to pay $2.50 of a deficiency payment. $2.50 deficiency payment. Now, if you go and work out the math then, they're paying $2.50 on 1.5 million. The government spending ends up being this chunk. And again, if we had real numbers here, that number will be an improvement over this situation. And then the other beauty of it is, that's different from this program, is that or different than a subsidy, I should say, as the market changes over time, if the demand for beef or corn or whatever we're talking about goes up, what happens to the government deficiency payment? It gets smaller and eventually goes away. All on autopilot, without a government official needing to do it at their own discretion. So by design, the policy is on kind of autopilot. That is, as the economy maybe grows and things change and the market price is up here, government disappears out of the picture automatically without an act of Congress to take away the program. All right. What else we got for problems? Any other homework problems that you wanted me to comment on or struggled with a little bit, or little niblets?
15, I think, age 15 and 17.
15. Let's start with that one. So 15 had the little graph mess up. I don't know which part were you, which part did you have trouble with?
I don't know, what is it? What's the age?
How much deadweight loss?
The tax creates the deadweight loss of a certain amount. So it was a deadweight loss. A lot of this problem is very similar to what we did in class. I don't know if what threw you was the graph. Did you have trouble? Did you look at the answer key and have trouble with the graph?
I ended up being just fine. I just had to have it walk me through it, especially on C, I think, when you...
Did I warn you guys of this, that the graph was off?
I don't think so.
Thought I meant to, sorry. This graph is wrong. The shaded area is not right. So, did that throw anybody? Did you look at that, or did you just work through the problem and do the math? If you didn't look at the graph, the numbers are all correct. So, the graph wouldn't have thrown you. So I won't spend time doing it if I don't need to. But on the deadweight loss, Adam, if you want me to talk about that part. This really is our kind of standard tax problem, similar to the one we did in lecture, where now this one they put the tax on the consumer, right? Which is a little strange, because we usually shifted the supply curve up, but we did say in class that you can also shift the demand curve down. And so if we tax the consumer using the inverse demand function, then you take away the tax, and that is effectively shifting this down by that amount. And so that ends up being here, if that's D1 and D2. The thing that the picture in the book screwed up is that the quantity after the tax, QT, is there. Here was free market. And the consumer is actually paying PC, and the producer is getting the lower amount. So the picture's coming together the same way. The amount of the tax was $1, right? So the vertical height here is $1. And what did QT end up being? 10? No, 10 was free market. 8.68. So we had 8.68 here. Are you guys, how many of you drew a picture to yourself as you worked through the problem? Yeah? Did you, Adam?
Yeah.
Okay. You what?
In their answer, they grabbed the inverse demand curve and they dropped it by $1 for the price in the home.
Which is what we did here.
Yeah, that's what makes
We dropped it by $1 effectively by the amount of the tax, because we were taxing the consumer.
I just didn't get why they used the inverse demand, not the regular demand curve.
Oh, always with taxes, we're dinking around with the price. So if you think about it, the inverse demand is price as a function of quantity, right? And so it's price that we're monkeying around with, is kind of the way my brain thinks about it. And so if we're going to subtract a tax off, we're using the inverse demand. It's P minus 1. It's the price that they would have been, that they're willing to pay minus 1. The story would be, what was the free market price? Did they give that even? Doesn't look like it.
I mean,
You could have solved for it. Or wait, did you?
you're supposed to, yeah. Free market price was
5? So the ideal, let me just tell you the intuition of it. The consumers used to be willing to pay 5 for 10 units, but now since the government's going to stock them with $1, they're only willing to pay 4. Their net price is 5 still, 4 to the producer, and $1 to the government. So their behavior is based off the combination of the tax and real price, so to speak. That's where their behavior is. And so we always maintain this real demand curve here because that's how they're going to behave. And so that's what ends up, solving for PC up here. The market is going to transact here with the quantity after the tax, and then the government gets the bump in the dollar.
And then the consumer surplus and producer surplus are just underneath the new PP on the side?
No, you got to be careful. So this is the price that the producer's getting. Let me get some real numbers in here. What is that? Did you calculate that?
PC.
467, and PC is 567. I probably could have figured that out. Okay. So that is the tax burden, the splitting of the tax. So in this case, consumers are paying a greater burden of the tax. That probably was that even asked in the problem?
Yeah.
Okay. So consumers bear a greater burden. That's due to the elasticities, the relative elasticities of supply and demand. What was your question, Max?
It asks for the change in producer surplus
Oh.
and consumer surplus.
So from the free market, consumer surplus was this. Now the consumer surplus is this. So they lost that whole amount.
Oh, so it doesn't drop underneath the second demand curve with the consumer surplus? You see that triangle?
Right. So it's always the real demand curve. I like to call this the fake demand curve because it's not really capturing all the information of the actual behavior of the consumers, but it creates this wedge between to reflect the tax part of it, which might have been decided by some bureaucrat, not the real market forces going on. Yep. Yeah, you got to work through a few of those problems. That's why I wanted you guys to hit this. I guess the last thing, unless somebody else has some other comments, again, this whole thing, you guys could get the exact same results by taking the supply curve and shifting it up by $1. Throw the tax on the producer. The new fake supply curve and the real demand curve are going to be here. PC's the same. Drop down to the real supply curve. PP is 467. QT is 868. It's all the same. So again, the moral of the story is it doesn't matter who we tax. If we tax consumers or producer, after the market works itself out, then the consumer and producer are going to both bear the burden of the tax according to their elasticities, relative elasticities of supply and demand. Okay. And good for 15? Anything else on that? Let's see. What'd you say, 17?
Do we have to do 17?
Yeah, I was going to say, I don't think 17 was assigned. 19 was.
Oh, it's 19.
11, 15.
My fault.
I think I skipped 17, even though it was starred.
Okay.
But I don't mind going through it. What was your question about it?
Well,
I don't think I shifted it for any.
I don't even know. Maybe I did mean 19.
Okay.
I didn't have
Did you mean the
17.
coffee one? Yeah, the coffee one's kind of a complex one too.
Yeah, no, it was rough. Both of them were rough. So.
All right. Well, let's look at the coffee one.
Is that 19 or 17?
That's 19. So consider the following fiscal scheme designed to directly transfer welfare from coffee drinkers to coffee vendors. The government will impose a dollar tax collected from the buyers for each cup of coffee sold. The government will then subsidize coffee vendors $1 for each cup of coffee sold. What will happen to the equilibrium price of coffee? What will happen to the equilibrium quantity of coffee? All right, so we're kind of doing and undoing.
So that doesn't mean you're gonna put a tax on subsidy.
Well, it is kind of, yes. So we're actually giving it back to them. So let's see. And I can't remember what let's see, the equilibrium quantity depends on the elasticity of supply and demand, therefore the change can occur in any direction. I was trying to think if this one I disagree. I have notes to myself on this one. All right, so what happens first? Let's just try to track it through together. Oh, you know, that happened to me in the other class too. Possessed. Okay. It's not really off, but well, this thing is not. Okay. The computer left or something. So, first part, what happens here? The tax. And we're taxing who? Consumers or producers?
I feel like we're always taxing consumers.
I think it's to kind of challenge you a little bit. And, you know, when you go to the cash register, who's paying that tax? It seems like you are, right? They ring it up and you pay it. But it turns out that that's the hidden part, that's the Econ part of it, that actually the producer's paying a little bit of it too. Okay, so we tax these guys, what is it, $1? But at the same time, we're going to subsidize the producers. All right, so how do we do that part of it? So producers are subsidized. Which direction does the supply curve move?
Move
To the up, down, left, right. So we're going to give them the dollar back, right?
So they want to produce more.
Yes, so they'd want to produce more, potentially, right? So we're going to give them the dollar right back. And so now, the interaction of the two, if they're all equal and the slopes stay constant, puts you right back where we started. So Q right back to the equilibrium by doing that. That one's a little bizarro in your head, but I had to work through it a little slowly too when I first did it. And then at this quantity, the real price received by the producer is, you go up to the supply curve, hang the left. The real price paid by the consumer, you go up to the demand curve, same thing. And what does that mean for producer and consumer surplus? Doesn't change. What does it mean for government revenue? If we're thinking of change in consumer surplus, change in producer surplus, change in government revenue. How much money does the government collect from the tax versus the amount of the subsidy? Nothing. So if they happen simultaneously, that would be the result.
So the price hasn't dropped out of the new equilibrium?
What's that?
So the equilibrium dropped in price, right, to the S2, D2? Or do you still go to the real supply?
This is the, no, this is kind of completely false. If they're both happening simultaneously, we never really get down to that point. Yeah.
19A in the book is that the equilibrium price will go down.
And I think they had that. Now let me see, maybe I jumped to the wrong thing here. How's the question worded on the first one? The equilibrium price of coffee would go down, PP before the subsidy. I think what they're talking about is this price before bringing up the subsidy and bringing it back up, it goes down. But I can't remember if it worded, it stays at, what will happen to the equilibrium price of coffee?
Before the subsidy?
Yeah. That was the only interpretation I could come up with to make it match what they put in the answer key. Was kind of telling it in stages. First we tax, then we give it back.
So why doesn't the price go down, like, overall?
Well, and actually the thing that, this one is a little bit complex because what do they put in here? In the first scheme, the subsidization has the effect on equilibrium price and quantity of coffee after the introduction of the tax. In particular, the subsidization will decrease the equilibrium price and increase the equilibrium quantity. In the second scheme, after the introduction of the tax, splitting the revenue among the coffee vendors does not cause any change to the equilibrium price and quantity. So that's our end result. What is the first scheme, though? Maybe I'm missing the... Consider the following fiscal scheme designed to transfer welfare from coffee drinkers to coffee vendors. The government will impose a $1 tax collected from the buyers for each cup of coffee sold. The government will then subsidize coffee vendors for each cup of coffee sold. Yeah, I don't see, I think they're trying to tell kind of a dynamic story. I think it makes more sense to just come back to the end. So I won't ask a test question for you on this because I wouldn't leave it that confusing, but if they're happening simultaneously, we get back, which is the picture they show on the final answer key is what we did here.
It's the same thing as the tax, you just add the subsidy.
Yeah. The question mark is the amount of money from the tax. If we go back and just do the tax and kind of freeze, the tax revenue here isn't enough to pay for the subsidy to get it back out to here. See what I mean? Because you're short some money to subsidize all, but that's not what's really happening. It's all happening simultaneously, and so QT never drops down to here. It all ends up right there. If they know ahead of time that that's the plan, you're going to get $1 for everyone, so that they're happening at the same time. Okay, any other questions on the problems?
What would your answer be for B? Like, what will happen to the equilibrium
and I think that's what they,
They said
It
it's
goes,
based on the
it
elasticity.
depends on the elasticity of the supply and demand.
yeah, I put that note to myself too, as long as the slopes have not changed, which the slopes are related to the elasticities, yeah. Yeah. If we just tell that story, which I don't think, to me, if both things are happening simultaneously, I don't think there's any reason to believe that the elasticities would change off the top of my head, so. All right, so let's move on to chapter 4 stuff. We have not done the learning curve stuff for 4, if I remember right?
So it's due by Sunday.
Yeah. Oh, I did say that. I haven't changed it on the system, but that's what I was planning was Sunday. So chapter 4, learning curve, and let's dig into. Oh, geez, we spent basically the whole time today. Well, I guess we had the presentation. So let's do.
You don't want these, do you?
No. So 4.3, we didn't finish off the video game person. So we've got enough time to do this. So Braden's budget. We started this one, but then we basically got into describing a budget constraint and the price ratio. So we had, what was it, rentals on the horizontal? Yeah. So quantity of rentals and quantity of candy. And candy was $1 each, so we could have 20. And games were 4, so 1, 2, 3, 4. We could be anywhere in between. All right, so is that about your picture that we left off with? And the slope of this line is negative, or you can just look at the numbers, do yourself a little rise over run here. 5, negative 5. But more importantly, we learned it was the price of something over the price of something. Which one goes on top? The price of rentals, yes, which is a little counterintuitive, but that is how our price ratio works. And if you write out the budget constraint equation in slope-intercept form, it's the slope, right? So that's the price ratio. And it tells us our ability to trade one good for the other, candy for rentals, our ability to trade one good for the other. And so that's the slope is the price ratio. All right, so then, assuming he spends 3, how many candy bars does Braden purchase if he chooses 3 video game rentals? How many candy bars does Braden purchase if he chooses to do 3 rentals? Answer? 5. 3 times 5 is 15. 5 times 1 is 5. $5 worth of candy bars, and 3 rentals gives us spending all of our money. It's a point on the budget constraint. Suppose, and part C, suppose that the price of video game rental falls from 5 to 4. What happens? So the price of rentals falls from $5 to $4. Okay, so if I spend all of my money on rentals now, I used to have an endpoint of all of my income of 20 divided by the price of rentals. I had 20 divided by a $5 rental gave me 4. Now I've got an endpoint of 5. How many more pieces of candy can I buy? How many more pieces of candy can I buy? I know you guys are tuned into other thoughts. With the changing of the price of rentals, how many more pieces of candy can I buy? None, right? So that doesn't change at all. All that's changed is the price of rentals. So the budget line rotates outward. And the slope has changed, of course, to -4. What if I had, from this red line now with the new prices, what if I had $5 more of income? What happens to the budget line? Shifts outward, right? Now, with income of 25, I could have 25 rentals, and I could have 5 more video games as well, or video game rentals. I could be out at 10. And so this is a parallel shift. My lines don't look too parallel because I don't have this drawn to scale, but this would be a parallel shift outward of the,
It wouldn't be 10.
I thought it would just be.
It wouldn't even be 6.
oh, because yeah, each one, we'd get 1 more. That's why it's looking a little weird. You are absolutely right.
Well, then you still have some left over.
And then we'd have some money left over. So let's just draw a nice parallel line and say that, what do we have, 6 and some, or 6 plus some money left over? So 6 would be over here. We could have 6 and a fraction of a rental, right? Technically it would look like that. Usually we don't do that to you on problems. But so 6 would be here, and we'd have a little bit of money left over, which we can't buy a rental, which would kind of put a constraint. In fact, you'll have some problems that are similar to that too, where if you can't buy a fraction of a rental, then your budget constraint ends up being limited right there. Okay? So income is a parallel shift, so kind of the key takeaway to have memorized is income changes lead to parallel shift, both directions. I got too many L's in there. Parallel shift. And price changes lead to rotation of the budget line. So we call this thing the budget line or budget constraint. So it's kind of rotating around the thing that didn't change. So you're going to have a different slope after that. So kind of remember those 2 things as you start to work through some of your problems. And then we still haven't tackled the big guy, which we'll do on Monday, but I want you guys to hit your learning curve first. Yeah?
So on C, when it says, suppose the price of the rental drops from $5 to $4, $5 is the old slope. That's the true price, right? Because that's what you have to give up in Canyon in order to get 1 rental.
No, that was the monetary price. So the price of rentals dropped. We used to be able to buy 4 rentals because they were $5 a pop. 20 divided by 5 is 4.
Yeah.
But when the price goes down to 4, I can buy more because then it's 20 divided by 4. Okay? All right. Have a good weekend. We'll